Alright, so the last lesson was solving equations with negative and fractional exponents. So that means that you know how to solve an equation when the variable is in the base, regardless of the exponent. An exponential equation means that the variable is the exponent, as opposed to negative fractional exponents where the variable is the base. So if the variable is in the exponent, then we have an exponential equation. So an example of that would be 2 to the x power equals 8. Now, this is a pretty elementary example in which you could say, well, I know that x has to be 3 here, because the only way we could raise 2 to a power to become 8 is if that power is 3. And in a sense, that's exactly how you're going to solve exponential equations. So now, this is an exponential equation because the variable is the exponent. So instead of just saying, oh, I know x is 3, we're going to show y. 2 to the x equals 2 to the what power? 2 to the third power. Now, from this step to this step, that's a substitution. I took a look at my original equation and said, I have a base of 2 and a base of 8. So how can I express 8 with a base of 2 if that exponent is 3? So now from this step to the next step, I can say that the bases are the same. The whole expressions are equal. Therefore, the exponents must be equal. Therefore, x equals 3. So now, what you're doing with an exponential equation, just write down some steps here. Step 1, substitute for your bases so they are the same. Step 2, cross out bases. Step 3, set exponents equal. And then solve resulting equation. So that's, in a nutshell, how you solve an exponential equation. This was a very elementary example. I'm going to go through a more difficult one now. Let's say we had 2 to the x plus 1 power equals 8 to the x minus 3 power. A little more difficult. Now, referring back to our last example, we have the same basis. So we're going to perform the same substitutions. So now you can never go up in base. Oh, that's not legible. Can't go up in base. You can only go down in base. And what you're doing, you're substituting for the larger base. A little shortcut, take a look at a smaller base and say, can I express this larger base in terms of the smaller base? In other words, can I express 8 with a base of 2? Yes, I can. 2 to the x plus 1 equals, and now I'm substituting for 8. Okay, I'm going to substitute for itself, apparently. So 8 can be expressed as 2 to the third power. Don't forget to rewrite your other exponent. So now I substituted for 8 with a base of 2. And now that my bases are the same, I can set the exponents equal. But before I do that, I have to distribute that 3. So we have 2 to the x plus 1 power equals 2 to the 3x minus 9 power. Now that the bases are the same, I can cross them out. So we have x plus 1 equals 3x minus 9. Let's subtract x from both sides. 1 equals 2x minus 9. Let's add 9 to both sides. 10 equals 2x. Finally, divide by 2, giving you x equals 5. And if you want to plug it in and check, feel free. 5 minus 3 is 2. 8 squared is 64. 5 plus 1 is 6, and 2 to 6 is 64. So therefore, we have solved correctly. Let's do an example where the common base is not written. So let's say we had 4 to the 2x power equals 8 to the x minus 1 power. So now we have to substitute for both the 4 and the 8 with a common base. Your first step should say, look at the smaller base and see if we could use that. Can we use 4 as a common base? Well, 4 to the first is 4. That'd be okay for that one. And 4 squared is 16. So we can't express 8 with a base of 4. But we can express both of these bases with a base of 2. So I know 2 squared is 4. Again, I'm substituting for this. And I know that 2 to the third is 8. Again, I'm substituting for that. Let's multiply our exponents together. 2 to the 4x equals 2 to the 3x minus 3. Don't forget to distribute. And now that the bases are the same, I can cross them out and set the exponents equal. 4x equals 3x minus 3. Subtract 3x from both sides, and you get x equals -3.